Hey, everybody. So this is just a lesson over section 11.7, only a one-day lesson. So this is going to be it. Next lesson is going to be a review over sections 11.6 and 11.7, and then we'll have our quiz at the end of the week. All right. All right, so here we get going. Okay, so what we're going to be looking at today is how do we add and subtract these radical expressions. So last week was how do we reduce radical expressions. And remember, we learned two ways to reduce radical expressions. We learned the factor tree method, and then we learned the perfect square method. Now, from here on out, I don't care which method you use. Okay, you could either use the factor tree method or the perfect square method. You'll probably, I bet more of you like the factor tree method, which is fine with me, and that's probably what I'll show in this video. Now, we only have to do that some of the times when adding and subtracting. Okay, so when do we know when we can add and subtract these radicals? All right, so adding and subtracting radical expressions, you can only do that when they have like radicals. Oh, and just remember, if you need to, the guided notes should have been right above this video. If you need to, make sure you get those and print them out if you need to, or just have them open and follow along and do your notes that way, whatever you'd like to do with that. But nonetheless, here, square root expressions can be added or subtracted when they have like radical terms. Here's what I mean by that, okay? Take a look. 2 radical 5 and 4 radical 5. 6 radical x and negative 2 radical x. 3 radical 4t and radical 4t. Notice how what's underneath the radicand, if you will, is always the same for ones that are called like radical terms. Okay. Now, these are unlike radical terms. 2 and radical 15, no good. 6 radical x and radical 6x. Notice this is the radicand is 6x, the radicand is x, not like radical terms. This one looks like it is, but it's not. 3 radical 2 and 2 radical 3 are not like radical terms. You can use like radical terms to add and subtract, okay? So think about it this way. You know, if I had, let me ask you this, what would 2x plus 4x be? Obviously 6x, right? When you have like variable terms, all you need to do is just add the numbers out front, add the coefficients, and then keep the same like term, right? Same exact thing happens with radicands. If you have the common radicand term, 2 radical 5 plus 4 radical 5 gets you 6 radical 5. Notice that it doesn't become 6 radical 10 or 6 radical 25 or anything like that. You don't add what's inside the radicand. It's just a like term, just like 6x and 4x doesn't make like 6x squared or something like that. You know, this is a plus sign, not a multiplication sign. So if I had 6 radical x and minus 2 radical x, that would be 4 radical x, right? 6 minus 2 is 4. Notice it's just like combining like terms. It's the same thing as, look, I just wrote that, yeah? Okay, same thing as if you have like radical terms. And it has to be the exact same radical term. Okay. So 9 radical 3 minus 4 radical 3. I do have like radical terms, so 9 minus 4 is 5. Yes, it's that simple. Don't change what's underneath the radical. A very common thing to do is try to make that like a radical 9 or something like that, or I don't even know. Yeah, this is radical 3, this is radical 3, this is radical 3. That has to carry throughout. Okay. 6 radical x plus 8 radical y. The radicand is x, the radicand is y. None. You can't simplify it any further because they're not like radical terms. Radical m minus 7 radical m. Now remember that you can always write a 1 out in front right there, right? So this is really like 1 minus 7 or negative 6 radical m. Okay, now when you have multiple terms, you just do the same thing as if it was 2x plus 2y plus 9x. Right? Or actually, why not? Let's just make this exactly like it is, right? If I took away the radicals and just had them in like variable terms, you'd just say, oh, 2xy plus 9xy is 11xy, right? Same thing here. 11 radical xy plus 2 radical y. Can I combine these two things? No, they're not the same radicand. They look very close, but they're not the same. Now, sometimes radicals do not appear to be like until you simplify them, okay? So like radical 45, I know I can do something with radical 45 because if I break that down, that's 5 times 9 and then 3 times 3, right? Okay, so that means that that is 3 times 3 times 5, or 3 radical 5. So the radicand is no longer a 45, but a 5. Okay, well, what's 20? That's 2 and 10 and 2 and 5. So that gets me a 2 times 2 times 5, or a 2 radical 5. Watch out, don't forget to bring the sign down. That's a minus sign. And look, I have like radical terms. Even though they didn't look like radical terms, they are radical terms in the end. So 3 radical 5 minus 2 radical 5 is 1 radical 5. Okay, and there it is. All right, next one up here. Radical 54 plus radical 24. Like right off the bat here, I don't know if I can add or subtract them, but I need to reduce it as much as I can first. So 2 times 27. Oops. Whoa. What the heck is going on? That's weird. I gotta get a pen there. Okay, there we go. 2 times 27 is 54. 3 times 9 is 27, and then 3 times 3. So I've got 2 times 3 times 3 times 3 as my prime factorization. So there's a 3 on the outside with a 6 on the inside. 2 and 12, 2 and 6, 2 and 3. So this is a 2 times 2 times 2 times 3. So a 2 radical 6. So they are like terms. 5 radical 6. Okay. Let's keep it going. Now, don't forget when there's a number out front, you have to continue to multiply that in front. So break down the 75. Oh, I hear my kiddo calling. Hold on just one second. Let me pause it real quick. Okay, and we're back. Sorry about that, folks. So we've got 9 radical 75 plus 2 radical 50. Sorry. Hold on a second, buddy. There you go. Is that better? Sorry. My kiddo's playing the Osmo right here. She got an Osmo for her birthday. Okay, so radical 75. Don't forget about this 9, right? I'm going to bring it all the way down right here, just so I don't forget about it. 75, that's 3 times 25, and then 5 times 5. So 3 times 5 times 5. Buddy up with the 5s. There's a 5 coming out and a 3 staying in. Okay, again, don't forget about the 2 coming down. Okay, 50 is 2 and 25, which is 5 and 5. So it's 2 times 5 times 5 with a 5 coming out and a 2 staying in. Now, here's the deal. Bring down the plus sign. This is 45. This is 10. But I cannot combine these. Okay? So we did something to it. So it's not just like we didn't do anything, but I just don't have like radical terms, so I can't combine it. It can't be like 55 radical 6 or something like that. All right, let's try it again. Okay, so 4 radical 27. Radical 27 is 3 times 9, and then 3 times 3. So 3 times 3 times 3. Pull that out. There's already a 4 that came down here. So 3 radical 3. And then 18 is 2 and 9 and 3 and 3. So 2 times 3 times 3. Buddy up with the 3, so minus 3 radical 2. Okay. And so that's a 12 radical 3 minus 3 radical 2. Again, we can't combine them. That's all we can do at that point. We reduce them down a little bit, but that's it. Okay. Let's take a look here. All right, so radical 12. This is 2 and 6 and 2 and 3. So 2 times 2 times 3 gives us 2 radical 3y. No y's come out because there's only a power of 1 here. And then this is a 27, so it's 3 and 9 and 3 and 3. So 3 times 3 times 3 gets us a plus 3 radical 3y. And this is when we can combine those like terms. So this is 2 radical 3y plus 3 radical 3y, or 5 radical 3y. Okay. That's what we've got for that one. Let's do one more of those. Now, when there's 3 terms, exactly the same thing. You just reduce them all and then see where you can combine them, where you cannot. So radical 75, that's 3 and 25, or 5 and 5. So 3 times 5 times 5, 5 radical 3y. Sorry, the neighbor's cutting the grass out there. 27, that's 3 and 9, and 3 and 3. Don't forget about the 2 coming out. Minus 2 times 3. 3 radical 3y. That's a times. So minus 6 radical 3y. And then 48, 2 and 24, 2 and 12, 2 and 6, 2 and 3. 2 times 2 times 2 times 2. 1, 2, 3. 4 2s and a 3. So 2 2s coming out. So a 4. And then a 3y staying in. And look, they're all like terms. 5 minus 6 plus 4. What's wrong, Sadie?
I can't make the monster what the monster.
Hold on. Hold on, kids. I gotta make a bird here. We'll make a big ring, and then use these 2 little blue ones here. And then here. And then maybe a blue thing coming off here. And maybe make a triangle beak. Boop. Boop. Put an eye in there. There we go. We got it.
Nope.
Okay. And we're back. Sorry, folks. All right. And this is the last problem. Okay. So find the perimeter of the triangle. Give the answer as a radical expression in simplest form. So remember that perimeter is just side plus side plus side. So in this case, I've just got to add to find the perimeter. It's just 3 radical 20 plus 13 radical 5 plus 10. Okay, so now I break this down. This is 2 and 10 and 2 and 5. So this gets me a 3 times 2 radical 5 plus 13 radical 5 plus 10. So 6 radical 5 plus 13 radical 5 plus 10, or 19 radical 5 plus 10. Notice that I don't make this 29 radical 5. I can't do that because this is a radical 5, this is a radical 5, but this does not have a radical 5 with it, so we're done there. All right, we should label our answer, so millimeters. There we go. All right, hope we're all having a good day. Talk to you later.